For this video, I picked out a mix of a series and a parallel circuit. I know a lot of students get confused about when to use parallel and when to use series rules, so I thought we'd go through this. Feel free to pause it and have a look at your equation sheet if you'd like to have a go yourself. But yeah, let's get started. To find the total resistance in this whole circuit, by the way, if it is a little bit blurry, I do apologize. But to find the total resistance, we're going to find the total resistance in this parallel junction here, the total resistance in this parallel junction, and then add together those two individual resistances because this whole junction is in series with this whole junction. So let's do that. We know that in parallel, 1 over the total resistance is given by 1 over the first resistor plus 1 over the second resistor, again and again for however many resistors there are. For this one on the left, the junction on the left that is, 1 over the total resistance is equal to 1 over this first resistor of 60 plus 1 over the second resistor of 60. 1 over 60 plus 1 over 60 is 2 over 60, which just simplifies to 1 over 30, because 2 divided by 2 is 1 and 60 divided by 2 is 30, and then you do the reciprocal of both sides. A lot of students do forget that last step, so do be careful of that. And that means that the resistance across this parallel junction here is 30 ohms. Let's now do the same for this parallel junction on the right. So we say 1 over the resistance of this total junction on the right is 1 over the first resistance plus 1 over the second resistance plus 1 over the third resistance for the three resistors. Now, adding these together, 1 plus 1 plus 1 is equal to 3 over 60. And just a reminder, we're able to do this because the denominators are the same, so we can add the numerators together. From there, you can simplify it, but let's not here. Let's just do the reciprocal of both sides to get that the resistance is 60 divided by 3. And I'm sure you guys know 60 divided by 3 is 20, so it's 20. Now that we've got the resistances of the both junctions, 30 for the one on the left and the 20 for the one on the right, they're in series like I mentioned before. So we say 30 plus 20 will give you the total resistance in the whole circuit, which in this case is 50 ohms. Let's now move on to part 2. It says calculate the potential difference across resistor Y. Okay, I'm going to erase some of this just because it did get a little bit messy, and yeah, when there's too much writing on the screen, I know some students don't like that. So you can skip ahead 5 seconds. I'm just going to very quickly erase some of this. I didn't know erasing was so hard. Okay, so what we know about voltage in series is that it splits up. The reason I mention that is because these two components here are in series. I want to show you guys a little trick, but if you already know this, how voltage and series vary in parallel and voltage and current vary in series and parallel, you just skip ahead 10 seconds. So what you guys need to know, I used to draw this table out and I used to write that in series, current always stays the same. And from there, I'd fill in everything else as the opposite. So voltage, therefore, in series would be split up. Current in parallel would be split up. And voltage in parallel would be the same. Like I mentioned before, this junction is in series with this junction. That means that the voltage splits up in series. How does it split up? Well, we know voltage is proportional to resistance. And we also know that the total junction resistances are 30 and 20 ohms. So it splits up in this ratio of 30 to 20. So let's do that. Let's split up the total voltage, 9 volts, into the ratio 30 to 20, which we can just simplify as 3 to 2. Well, when you do that, we do 9 divided by the total number of parts, and then you multiply by how many parts you want to go into. For example, we're trying to find the voltage across resistor Y. So let's multiply it by 3 to get what 3 parts represents. In this case, that would multiply to give you 5.4 volts. Similarly, you could do the same process to find the total voltage going through the junction on the right by doing the total voltage of 9 divided by the ratio that you're dividing into, so 3 plus 2 is 5, and then multiply by what specific part you're trying to get into, which is this junction on the right, which represents a ratio of 2. And that'll get you 3.6 volts. What you see now is that the total voltage of 9 volts is split in the ratio of 3 to 2, 5.4 to 3.6. Like we mentioned, 5.4 volts flows into this junction on the left, and because in parallel voltage is the same, both top and bottom of the junction receive 5.4 volts. It doesn't split up. And so your answer, the voltage through resistor Y is just 5.4 volts. That's it for that question. Sorry if I'm moving my mouse around a lot. I just noticed it. Moving on to this next part of the question, it's asking you to find the charge through the resistor Y in 2 minutes. What equation relates charge into electricity? Well, it's actually charge equals current multiplied by time. We have the time. Of course, you have to remember that to convert that into seconds. So that's 2 times 60. But we don't have the current flowing through resistor Y. What we have found is the voltage through resistor Y, and we also know the resistance through resistor Y. We also know that current is voltage divided by resistance. In this case, we can do the voltage of 5.4 flowing through Y divided by the resistance of Y, and you can multiply onto that the time, 2 times 60. When you multiply all these together in a calculator, you'll get a value of 10.8, and charge is measured in coulombs, so let's represent that by a capital C. But if you did want to know the spelling, it's COULOMBS. Moving on to the last part of the second question, the energy dissipated in resistor Y. Well, the equation that links energy into electric circuits is power multiplied by time. Because we have the voltage and resistance, there is an equation linking power to voltage and resistance. That's V squared over R multiplied by time. V is equal to 5.4, so it's 5.4 all squared. By the way, if you think I'm going too fast, I'm doing it on purpose actually, because most students like it when I go fast, but you can always rewind. I do apologize. You divide by the resistance of Y, which is 60, and you multiply by the time, again in seconds. So right now we have time in minutes, but 1 minute is 60 seconds, so we multiply by 60. That will get you a value of 58.32, and let's just write 58.3 just to keep it to 3 significant figures and consistent with this one here. The unit, by the way, would just be joules, but that's already listed here, so you don't need to mention that. And yeah, that's everything for that question. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.